All righty, good morning, good evening, and good afternoon. I'm Micah Robison, IBM Storage Vice President for Enterprise Development. We're excited and welcome you to our new launch of this new live webinar series, IBM Storage Unplugged, Unfiltered Insights for Storage Users by the Developers. We have already been receiving a overwhelming response in terms of subscribers, so thank you, thank you, thank you. This series is going to be successful because of you, because of the interactions you bring to it, and hopefully you share it with everybody. We are recording these, and so you'll be able to watch them afterwards as well. So let me take you through the why, the how, and the what of the series that we're going to do, and then we're going to jump straight in. So why are we doing this? We consistently get feedback from customers and business partners that we have many new features and new technologies, but they're unknown or they go underutilized. So this webinar is designed to bridge that awareness gap. We want to create a catalyst for the new features, ensuring that innovations are not just launched, but also that they're understood, that they're adopted, and leveraged effectively. So all of this is going to bring value back to you and your companies. So we're thrilled that we're going to be launching this series. Again, this is by the development team. We're excited to have the architects and the developers here that are going to be able to present to you, that you're going to be able to interact with. So our goal is to help you, one, to stay updated on the latest IBM storage technologies. Number two, to discover new product features and innovations. And number three, to connect with the minds behind those solutions. So how is this going to work? Every 3 weeks, we're going to host another webinar. Each of those webinars are going to be 30 to 60 minutes. To start out, we're going to be focusing on topics around flash systems and storage insights. However, we're going to approach this in a very on-demand way. So we want to listen to the subscribers and the feedback that you're going to give to us, and that's going to drive the topics of the future that we're going to be dynamic in our agendas. So again, please provide that feedback to us so that we can then know where you are interested in hearing on the various storage topics. You might be asking yourself, so how is this different than other IBM storage webinars, such as Storage Talk or Accelerate with IBM Storage or Flash in a Flash? This series is going to complement those, but this series is going to be unique because it's going to be presented directly by our development team. You're going to be able to interact directly with us and the architects and everybody who is shaping the IBM storage. So as the name suggests, these sessions are intended to be unplugged or unfiltered, coming directly from developers. And as I said, they're live, so it could get interesting at times, but hopefully things go smoothly. So we ask for a little forgiveness if things go off the rails because of technologies or whatnot, because they are live. So what are you going to get out of this? We're going to focus on technology behind the features. So you often get the marketing messages, you get the features, the new launches, the announcements. We're going to focus on the technology behind all of that. We're going to discuss use cases. We're going to do demos. Again, that could be where we go off some rails, but we're going to do live demos for you. And it's going to be driven by facts, not just the fads. So one of the key things that we want to focus on in the format of what we're doing here is to focus on Q&A. Again, we want that interaction with you. This is your opportunity to talk directly to developers and get the answers as well. So I hope you're excited for everything that we have in store. We have interesting topics already lined up for the next few sessions. And now, without further ado, we're going to jump straight into this series. So our first guest is Chris Bulmer. Chris is based out of Hursley in the United Kingdom. He is an architect on flash systems in our replication space, leading the architecture for policy-based high availability replication. So, Chris, I will hand the mic over to you. And again, thank you everybody for joining, and continue to spread the message so we can continue to make this a wonderful series. Thanks.
All right.
Over to you, Chris.
Thank you very much, Micah. So, as Micah said, amongst a few other responsibilities, I have our high availability and replication architecture. So this is going to be an overview of what we have, particularly in the high availability space, and our strategic directions going forward with policy-based HA. So The last, I want to say about 6 years has been quite busy for us in the replication space. During that time, we've completely redesigned and re-implemented our entire replication and high availability technology that we have in the products. So while work started, I want to say back around 2018 or 2019, the first release was in 2022 in the 852 release, and we announced something called policy-based replication. This was a ground-up redesign of our entire asynchronous replication technology to the product, effectively replacing global mirror and global mirror change volumes with a single solution. We do have a statement of direction that was published about 18 months ago for a synchronous version. So currently, policy-based replication is async, but as a statement of direction says, we are working towards a synchronous version. We followed that up a year later, in around September 2023, with what we called policy-based high availability. This was the natural successor to things like Hyperswap and Stretch Cluster, focusing on how we can achieve a highly performant HA solution, but between independent systems. And I'm going to go through that in a lot more detail in the session. And then in the third quarter of last year, we actually allowed you to combine both of those. So we don't want our high availability and DR solutions to feel like a separate thing. If we want HA plus DR, just do that. It doesn't need to be like a separate offering. It's a combination of two existing powerful features. So as part of this, we redesigned how we think about replication. And the core to that was something that we called the storage partition. The partition itself is effectively a logical container for a number of workloads to be running within. There's no hard and fast rule about how we use storage partitions. We could see some customers using one partition for their entire system, whereas others may want to have lots. So you could have one per application, perhaps, or one per internal department. There really isn't a rule about how to do that. But fundamentally, when it comes to replication, the storage partition is a key concept for what we want to do in this space. And it all starts with creating a partition and hitting that configure replication button. But stepping back from that a moment, there's often a lot of confusion about volume groups versus storage partitions. Volume groups are a collection of volumes. And within the volume group, this is where we put volumes that need to be related together. So they could be data stores for a vSphere cluster, or they could be all the volumes needed for an IBM IL car, for example, an ASP. And the reason for using volume groups is this defines the boundaries of consistency for replication and for snapshots. So if we were to assign, say, a snapshot policy to our volume groups, all of the volumes in that volume group are considered to be mutually consistent in those snapshots. Likewise, for replication, with policy-based replication, we assign that replication policy to the volume group itself, and the system takes care of replicating that volume group in a consistent manner. You don't have to use volume groups for consistency if you don't want to. If you can put lots of disjoint volumes in there and just treat it as a management construct, it doesn't necessarily need that mutual consistency. Often that can be a benefit even if you don't intend it to be. For example, you could have a single recovery point for your entire company, so you don't have to worry about recovering multiple different applications back to different points and dealing with their inconsistencies. You can just roll back everything to a single recovery point. Then as I said earlier, the storage container kind of wraps those, and this is a logical entity for one or more volume groups. We don't actually have a limit on the number of volume groups that you can have in a storage partition. We support up to the system limit of 1,024 in a single partition if you wish. And then on the storage partition, we can assign high availability to it, or we can migrate it to another member of FlashSystem grid independently. But the storage partition is a key component for our replication technologies, as well as lots of other pieces of the products going forward. So once we hit that button to say, what do you want to do with your partition, we get the option of how we would like to configure this. And we can always come back to this menu later. But if we say we want to start with policy-based high availability, because we want an HA system between two independent systems. After selecting that, There's a couple of questions of which other system do you want to partner with, and that's pretty much it. A lot of the rest is automatic. And then at that point there, it will start synchronizing. If you don't have any existing volumes or volume groups in the storage partition, then there's nothing to synchronize. Otherwise, it will start that background process. Unlike with our older technologies, you don't have to manage the synchronization process manually. All of the bandwidth management is handled automatically by the code. So as well as improving the usability, we also wanted to improve a lot of the internals. We don't want you to have to choose between, this is my partnership bandwidth and this is how much of that as a percentage I want to use for resynchronization. No, take that all away and let's make it a simple solution to begin with. So it balances the background synchronization traffic with any host writes that are coming on to make sure that they're appropriately mirrored. It also does all of the configuration for you on the remote system. So once we have the partnership established to the remote system, that gives us authority to go and do remote provisioning. So as part of this establishment of high availability, it will create all the equivalent volumes on the remote system. It will create the host clusters, the host mapping, the volume groups, and then start the data synchronization into it. So you never actually need to log on to that remote system to be able to configure high availability. So once that has synchronized up to its kind of baseline state, we're then in an established state. And one of the things we want to be able to do is to consider that high availability is not just data. It's a lot, in today's workloads, it's a lot more about the management plane as well. Because while, for example, let's take a vSphere cluster, if you're unable to take snapshots during a disaster, if your HA's failed over, or you want to have kind of external orchestration running against your cluster, then the inability for that to run when one of the systems is offline is often as much of an impact as losing access to the data for many workloads, because you can't recover, you can't take snapshots, you can't clone, for example, you can't do new provisioning. And for that reason, we also allow a storage partition to be assigned an IP address. And if HA does happen to fail over, that management IP tracks the storage partition so that it always has a single highly available endpoint that you can perform configuration tasks with. And then if it at that point there, when the partnership or whatever the problem was is resolved, any configuration changes that you make is automatically rolled forward. So it's not like managing two independent systems. You don't need to go and create your host mappings on the second system or your host objects. All of that is completely transparent, regardless of what the system state is, and it will roll forward into that safe state. So once we get to the HA established state, we have active access through both systems. So our applications can perform I/O to either system, and it's mirrored. We'll talk more about how to kind of do host routing in a moment, but any snapshots we take are automatically mirrored as well between the two systems, so that if we do have a disaster, we can just restore back from the snapshot without any impact to high availability, or we can clone new volumes from existing snapshots as well. So really building in a lot of our richer features around data protection into HA. It shouldn't really feel like a collection of independent features working together. It's just kind of a holistic solution, looking at all of the different capabilities we have in the FlashSystem portfolio. So simplicity was one of the key motivators in redesigning our entire replication solutions. Another was around performance. Today's workloads are getting more and more demanding with what they expect of storage, and storage can offer a lot to today's workload. As we move closer and closer towards microsecond latencies, being able to deliver that with highly available solutions really helps accelerate the performance of your applications. So one of the other pieces was that performance piece. And what we can see here is particularly interesting is this blue line compared to the orange line. The orange line is a baseline performance measurement for a FlashSystem 9500, up to a certain workload anyway. Where we are with policy-based HA is there's a very minimal overhead to the response time with when HA is configured and running. It will never be the same latency as what we can achieve without any sort of high availability, because there does need to be a synchronous mirroring to a remote system. And that does take a little bit of time. Even if these systems are together, these are about 1 rack apart from this measurement, but that does have a very small overhead in terms of microseconds. And it just adds up to a tiny bit of latency. So you're not going to see exactly the same latency as what you could see in a non-replicated or non-HA workload, purely because of physics. But where we are is we're actually very, very close to the baseline of our system, where we're probably adding, in most cases, a fraction of a millisecond into the latency to do that mirroring, which means that you're able to replicate at several gigabytes per second of write throughput. I think we're up to about 6 or 7 gigabytes per second of write throughput, plus a lot of read throughput on the 9500s at these sort of benchmarks of 16K. So it gets you a lot of kind of flexibility for those workloads, ensuring that we actually can protect them and keep them highly performant. So let's talk a bit about how high availability actually behaves. So there's several parts to an HA solution. We have our pair of systems here. So on the left-hand side, we have a flash system. I think it's a 7200 here. And on the right-hand side, we have a pair of SVC nodes. Unlike things like Hyperswap or Stretch Cluster, we don't have the requirement that you have symmetric hardware between the two systems. We can have different systems. We can also have different code versions. So you don't have the requirement of them being clustered. And the different code versions also allows you to perform different software upgrades on different systems at different times. But what we have here is we've got some servers running to a couple of volume groups inside our storage partition. A partition itself has a concept of management systems. And typically, in normal running, management is performed through only one of the two systems. And any of those changes are automatically replicated to the HA partner. And we refer to that as the management system for the partition. There is an attribute, which is the preferred management system, which says, in normal running, I would like this system to be the management system for this partition. That also influences how the partition acts if the systems disconnect, as we would always prefer to keep running on the preferred management system. It's the least impact in terms of we don't need to fail over IP addresses, and we're keeping it where you want to run it. So in this case, let's say we lose connectivity between the two data centers. The first thing that happens is nothing. So we wait for a few seconds before doing anything. Many times when looking at how things like our Stretch Cluster or Hyperswap solutions behave, is link glitches are very temporary. The ISL might be having a bad moment and it recovers in 200 milliseconds. We don't want to commit to breaking HA and then having to do a lot of resynchronization for a small glitch. What we want to be able to do is ride through that. So for a couple of seconds, we sit there and do absolutely nothing. If the link reconnects in that time, it gets on as if nothing happened. But in the case where it doesn't, we commit to breaking HA and we start these quorum races. So the quorum race actually happens in multiple phases. So the first phase is that the two systems will try and lock the quorum device for partitions which they are the management system of. And both systems will be doing this independently. If they fail to get that one, because, for example, they can't access the quorum device because all external connectivity from the data center is down, then we'll have a partition failover. But the normal case in that when both the systems are online and healthy, we'll be able to lock the quorum device for the partitions that system is the management one for. A few seconds later, it will try and lock the quorum application for the HA partner's storage partitions. And if it manages to do that, it will assume running. And what that typically translates to is an IO pause of about 8 seconds, while HA works out what the state of the world is, connecting to the quorum application and locking all of the quorum devices, and then suspending HA and potentially failing over. And what we typically see is that IO has a small stall for a few seconds and then resumes, no applications failing during that time. Let's say we have a different partition, in this case in light blue, that prefers the right-hand side system. Exactly the same thing is happening from that system. It's trying to lock the quorum device and in this case achieves it and keeps the volumes online on the right-hand side system. When the link reconnects, everything is automatic. And if there are no other errors, then HA will start re-establishing automatically. So rolling forward any configuration changes that were made on either system while HA was disconnected, as well as doing an incremental resynchronization of any data that was changed while disconnected. We will never do a full synchronization unless there's no baseline image to replicate across. So once HA is fully resynchronized, it will go back to that fully active symmetric state where either system can support writes. Storage partitions actually replicate independently, so you could have 20 more partitions on the system. Maybe they have a lot more data to replicate and they're still catching up. But as soon as the volume groups for one storage partition are completing their synchronization, that partition goes back to its active state. So in these diagrams, I've just drawn for simplicity, saying that the preferred system is the preferred paths to the host. That's the default behavior. That's not really how most of our systems are actually deployed, though. What we tend to have is distinct sets of compute in different data centers. It could be 2 racks within the same data center, for example. And what we would typically see is that there's an ISL between the switches. There will be typically redundant fabrics here, but I was lazy and didn't draw it. And we would have I/O going to the preferred system. Now that's not really optimal in this scenario for the servers on the right-hand side. So the left-hand side, great, yeah, they're really nice and close to the storage. They're going to get the best possible latency, but we don't want to be going over ourselves if we can avoid it. What we can do is we can assign locations to the servers, and that says these servers are co-located with this storage array. And what that means in practice is that the right-hand side system will send all of its I/O to the right-hand side system. For reads, that's excellent. You can do local reads and you get the benefit of the flash system and the FCMs for that really ultra-low latency reads. Writes still need to cross the ISL. That's the same for both systems. We're not going to kind of suddenly teleport the data to the remote system. It does need to send this. We have to cope with that round trip time. The data does only cross the ISL once. And if we have a disaster, then of course, if there's no accessible copy on the local data center, it has to cross the ISL. But as soon as it's fully re-established, the path will reappear on that right-hand side system, and it will go back to using the paths to that particular array. To assign the location, the easiest way is to use the UI. There's a right-click menu, or there's in the newer designs, it's under the Actions menu, just to say edit the host and assign a location. We moved away from the concept we had with our older HA technologies of having to go through this concept called a site, and you put nodes into sites. And now we just say it's with that array. That keeps it nice and simple. So let's say we've got our HA partition. Now we want to add a third site for even better protection. So under the 3 dots overview on the storage partition, we have this option to add disaster recovery. And if I click on that, I'll get the option to choose which system. So if I click the configure partnership, I'll get a list of all the partnerships that I have. If I only have one storage pool, then it auto links. And if I'm using child pools or multiple different pools, then you'll need to link any additional pools. But there's a GUI work through just to say, this one goes to that one, this one goes to that one. And we also create a storage partition in the DR system. Once that's done, we can create and assign our replication policies to our volume groups. We don't assign replication policies for async or even DR in general to the partition. We assign those to individual volume groups. The reason for that is you might not want to replicate everything to the third system. You also might want to have different RPOs for the different volume groups you have in the partitions. So that doing it this way gives you flexibility of HA still established at that partition level, and all the failover and failback is happening transparently if needed. But replication is a choice on per volume group. Even if there is an HA problem once 3 sites are set up, replication down to that third site is automatic. It just follows the preferred system for the partition, and that's also the replication source for those volume groups down to that third system. But it will fail over seamlessly if HA fails over it to keep replicating. We don't want to be in a position where our DR site becomes stale just because HA has happened to have a problem with one of the two systems. So internally, we had a lot of simplification for our async replication as well. Using a lot of the same philosophies that I've just spoken about with high availability, making it very policy driven, making it very simple to use and highly performant were the key design decisions that we took as part of the implementation. So way back in 2019, when we were thinking about this, we looked at how replication is performed, not just within IBM, but across the industry. There's typically two modes. We see kind of a streaming continuous based replication, which we refer to as journaling mode. If you're familiar with Global Mirror, we would consider Global Mirror to be a streaming or journaling mode based replication. And then we have a snapshot based replication. So the weird thing that we were thinking is, why do you have to choose? This should really be automatic. We don't want to be in a situation where you have to choose upfront whether you want to have a kind of a low recovery point, high bandwidth solution, or have a low bandwidth but higher recovery point option. You kind of want to have the best of both worlds, where when conditions are good, you get the lowest possible recovery point. But if we are congested or we don't have enough link bandwidth or write performance on the DR system, then we want to be able to switch to automatically to be using that snapshot-based mode of replication. And this means that you don't have as many decision points and everything can be handled automatically by the code, really trying to get to that simple as possible deployment of replication. So the way that the journaling mode works is we allocate a large amount of memory within the array for effectively a volatile journal. And the amount of memory is dependent on the amount of memory that we have available per node. But our higher end nodes, I think if you get above, I want to say 256 gigabytes of memory per node, then we have 32 gigabytes of journal per node. So for 64 gigabytes per system or per IO group, depending on if you're supporting a multiple IO group system. So we can buffer a lot of data into that. That's typically going to be many seconds worth of write throughput. Maybe on some applications, it might be 5 to 10 seconds. On other applications, it could be minutes. And that allows us to be very proactive about how we handle replication. Effectively, that journal is just a ring buffer. So writes come in and a little head pointer goes around finding the next write to replicate and sending it across to the remote system. And once it's got acknowledgements back, it clears it from the ring buffer, so that slot can be reused. The benefit of this is that we can look to see how full that ring buffer is. And if we're starting to run low on resources, i.e. memory, because that ring buffer is getting full, we can look at what's happening in the system. We look at what is the recovery point objective for each of the volume groups. The recovery point objective comes from the replication policy associated with it. And then we can look at how much throughput is this particular volume group actually using. And there's an algorithm that goes through and ranks those. So ranking first by throughput and then by RPO. And what it's trying to do is to find which volume groups it is contributing significantly to resource consumption in that journal, but has the highest recovery point objective. There's no point doing anything about, you could have a volume group with an RPO of 1 day, but if it's not sending any data, then don't do anything with it. It's a pointless operation. You want to be trying to do as little possible changes to get to the point where everything can meet its recovery point objective. And that's the continual goal of what this algorithm is trying to achieve. So in this mode, data is replicating out of the journal, but we may, if that journal comes full, switch to our snapshot-based mode of replication, which I'll talk about in a second. In this mode, typically recovery points are measured in tens of milliseconds. It's not uncommon to have a recovery point of, say, 50 milliseconds in this. Obviously, it's going to be dependent on the round trip to the remote system. If the round trip is 200 milliseconds, you're not going to get a 50 millisecond recovery point. That's probably going to be half a second or higher. But that, as I said earlier, that journal is volatile. And we do back it up with a non-volatile bitmap, which effectively says, in the journal, I currently have these regions of the volumes which have data. And we can say that if we, for one reason, one node goes offline, or it's upgrading or something like that, or we just run out of journal memory and we have to discard the contents, we know exactly what data we just need to replay to the remote system. So the second mode is this cycling or snapshot-based type of replication. It's a fairly common approach across most block storage products. And the way that this works is it periodically takes a snapshot and then synchronizes that snapshot to the remote system and does that in a loop. We had this implementation with Global Mirror with change volumes. And while there's a lot of internal improvements, both in terms of throughput and in terms of response time that we have with this newer solution, the actual philosophy is the same. And the benefit of this approach is you can coalesce writes. Many applications are not writing a truly random workload. They're writing frequently to the same regions of the volume. So it could be metadata regions, it could just be where the database happens to be currently doing its work, or it could be a few files in the file system. We can collapse down each of the write stream into what was the last write in that period for that particular set of blocks, and then we can replicate that once. So you can actually achieve a significant reduction in the bandwidth required for replication, because effectively you're almost doing like a deduplication of data, getting down to only what the last data is that you actually care about and omitting all of the earlier ones. And that makes it really good for long distance or low bandwidth links, or when we're just congested on the ISLs or links or whatever. So internally, we use, like GMCV, we use change volumes. These are automatically provisioned on the system as part of configuring replication. They're kind of hidden there in the background as well. And we'll move volume groups into this mode when we effectively can't keep up in that ring buffer of the journal. So once a volume group is in this mode, there's no fixed cycle time. It operates purely based on how long until the recovery point objective is exceeded for this volume group. It'll be trying to cycle 2 to 3 times in that period. So if you have a very long RPO, say 24 hours, it's going to be cycling every 8 hours. If you have a 10-minute RPO, it's going to be cycling every 3 minutes. It'll be monitoring constantly how the behavior of cycling mode is going, because it always wants to get back into that low recovery point mode of journaling. So it's looking at how long did that cycle take? How long would that have taken if I was in journaling mode? And then going, actually, compare this to what the recovery point objective is. Would I be able to sustain journaling mode? And if the answer is yes, then it will switch back to journaling mode and try it. Following kind of many different principles here, but one of them is try it and see what happens. Most of the time, if we think the workload has now dropped to a point where it's low enough, journaling mode's fine. And what we see in practice at a lot of our customers is that throughout the business day, they're in that journaling mode with very low recovery points. Overnight, they may have large batch workloads running, which exceed the link capabilities. And instead of pushing back onto the application and causing higher response times, we want to just extend the recovery point. We don't want to cause application performance problems. So we can switch those volume groups for the hour or two that these batch workloads are running to this particular mode. And those batch workloads will complete. It will complete its synchronization and then switch back to journaling within a couple of hours. So the net of this is a significant improvement in how our replication behaves compared to the previous generation of Global Mirror. Again, the yellow line is the baseline here of what a non-replicated set of volumes can achieve on this configuration. Again, this is a pair of FlashSystem 9500s. The red line here is what Global Mirror could achieve. So it typically had software bottlenecks which was one of the reasons of this entirely new design. So where we are with policy-based replication is that it can effectively be within a small margin of what the baseline system can actually achieve. As it gets further and further to the right-hand side of the system, we stop plotting, as at that point there, we were actually ran out of link bandwidth to the remote system. The flash system itself could actually continue for quite a lot more throughput. But we're at the point now where both our high availability and our replication solutions can keep up with today's modern workloads, getting the best out of the flash system hardware and all the SBC hardware, really utilizing a lot of the advancements we've had in both hardware and software advancements over the last 10 years, to making sure that we do truly have a kind of a high availability or DR solution that is fit for modern enterprise workloads. So with that, I think that is all of the content I've read. Yes, it is. If there are any questions, I can take a look and we can go through some of them. Have we got the chat enabled? If you want to put any questions in there, you're more than welcome. Right, not seeing any there, but I'll give that a moment. Otherwise, Micah, anything you want to say?
No, this has been good. I appreciate you going through this, Chris, and digging in deeper. Again, it looks like somebody just put in a note. I just wanted to say thank you, and this was great. So appreciate that feedback, Scott. Again, hopefully everybody can make this interactive as we go forward. Even during the sessions as we're doing this, feel free to pop questions in. The developers will be watching. Be sure to share this. And Piyush, do you want to say any final comments?
Oh, thank you. Thanks, Micah, for kicking it off. I'm really excited that this new platform will help us to bring content which is really complementing some of the other webinars. And I will just reiterate that this recording would be also made available to our YouTube channel, Storage Guru. We have our channel called Storage Guru, where we keep a lot of content created by the developers. So we are planning to put a new playlist there with all the recordings of these videos. So you will people who could not join today will also be able to see that, as well as if you want to go back and refer the session, then you will have that recording available there. So yeah, with that, thank you very much, and you will just. Sorry.
Just to pause it, there are a couple of questions now. So there was one to say, is there any reason not to use this as a non-disruptive migration process? Absolutely not. In fact, that's what we do for our partition migration. So if I got an option to go way back to kind of, long way back. So once we have our storage partition, what we can do, it's not that in the managed partition for non-HA partitions, there's an option to migrate. And we do this at, I think, the flash system grid level to say, we can migrate this partition non-disruptively to another member of a flash system grid node. I'm pretty sure we'll probably have one of these sessions on flash system grid at some point in the next few months. And under the covers, it's working through establishing high availability to deal with the all of the remote provisioning. It synchronizes the data, but we also have a number of other checks in there. So as part of the workflow for the migration, we do a lot of host path checking. Have all of the servers we think logged in? Do we think that they're actually discovered the volumes, and are they doing I/O to the new volumes? As well as keeping all of our replication going while doing that migration. So yes, it's a great idea to use policy-based HA to do this migration, so much so we did it and made it automatic.
There's another question specific to that, William.
Yeah. So what are the challenges that made us go for policy-based high availability before we got to synchronous policy-based replication? A choice of direction, or does it represent a more significant challenge? It's a good question. It was really around how we saw a lot of our customers use our existing technologies. We had a lot more customers using Hyperswap or Stretch Cluster compared to Metro Mirror. So for us, it made a lot of sense to use kind of HA as kind of the next deliverable instead of synchronous DR. There was also feedback from a lot of our customers that actually synchronous DR is probably better for them. So, for example, we had some customers who were really happy that they no longer had to use SRA on VMware. Moving all of the failovers to be completely automatic at the storage level, it just made it completely transparent to them, and there was less to manage in their entire environment. But in terms of does it represent a more significant challenge? No, not really. There's a lot of commonality between high availability and how synchronous DR work. Fundamentally, they're both kind of receive a write to both places and then complete it back. High availability is actually a superset of synchronous replication in terms of complexity. All right, I think that was the questions. So sorry, Piyush, back to you.
Yep. Thank you. Thanks, Chris, for answering all the questions. And I was just making the final comment that, as Micah already highlighted, the agenda and the topics, we are very flexible. And while we have a list of topics to cover, but we will fine-tune, adjust it based on the demand. So I would say this is that webinar which you can drive the way you want, that you can tell us what topic you want to hear, and we will prioritize those topics. So yeah, just keep watching the emails, as if you're subscribed. And you have the forms which Pradeep will send, where you can provide your wish list, and we will keep that in consideration. Thank you very much.
Thank you, everyone.
Thank you. Thanks. Bye-bye.